Imagine a robot wandering through a warehouse, trying to map its surroundings. It's like a detective searching for clues. Every time it sees a familiar shelf or doorway, it thinks, hey, I've been here before. But here's the catch. In places with lots of repeating patterns, like a maze of identical aisles, those clues can trick the robot. It might think it's back at the start, when it's actually just in a similar spot. That's where loop closure detection comes in. Loop closure is the robot's way of saying, wait, did I just loop back? Let me check. But if it gets this wrong, it can completely mess up its map. Think of it like a GPS that suddenly thinks you're in a different city, because the buildings look the same. Traditional methods rely on visual cues, like comparing images of shelves or doors. But in repetitive environments, those cues are too similar. It's like trying to tell apart identical twins. That's where our new method, ROVER, steps in. ROVER doesn't just look at what the robot sees, it also remembers how it got there. Think of it like a human navigating a hotel. If you walk through the same hallway twice, you know you're in the same place, not a copy. ROVER uses the robot's trajectory, its path and movements, as a built-in truth check. Here's how it works. When the robot thinks it's found a loop, ROVER simulates what its path would look like with and without that loop. If adding the loop makes the path jumpy or chaotic, it's a fake. But if the path stays smooth and logical, it's probably real. It's like checking if a puzzle piece fits by seeing if the whole picture makes sense. The team tested ROVER in tricky scenarios, like a warehouse with identical shelves or a parking garage with repeating patterns. Traditional methods failed, but ROVER nailed it. And here's the kicker. It works with any sensor, whether the robot is using cameras, LiDAR, or radar. That makes it super flexible for real-world robots. So next time you see a robot navigating a complex environment, remember, it's not just relying on what it sees. It's using smart tricks like ROVER to stay on track. And if you want to dive deeper into how this works, check the link in the description, because science is always cooler when you see the code behind it. Thanks for watching, stay curious, and let me know your thoughts below.